So, good evening everyone. This is Daniel and I have here with me today your classmates Pablo, Luis and Sofía. We would like to welcome all of you to this presentation about FastCheck, a testing framework implemented for JavaScript and TypeScript. My colleagues and I will guide you through a not so small introduction to this mentioned framework. First, I will give you an introductory explanation to what FastCheck is based on, what basic concepts we can expect to manage when working with it, and I will also work on this exposition with the help of a couple of down-to-earth examples, which I hope will make things fairly easy to understand. And later on, my colleagues will guide you through other aspects of this framework, which are more specific to FastCheck. It is also worth mentioning that the concepts that I will introduce you to will for sure sink in as the exposition progresses, so don't worry if you don't understand something right away. And so now, without further ado, let's start with introduction by getting to know some of those common vocabulary concepts that will be recurrent throughout this whole presentation. These are property testing, or generative testing as it is also called, the concept of property law or invariant with relation to tests, what test generation means, and what happens when non-deterministic test execution kicks in. Although this might surprise you, these last two concepts are actually self-explanatory, and maybe you can dig out a point of why they need to be explained, but you will realize that they need to have a spot in this explanation as they will fit into the examples naturally. First, property testing or generative testing as it is sometimes called. So, when we are implementing something new, both the code itself and its tests, we want this to check something that happens when our code gets executed, right? For instance, when we sort an array, we want to know whether or not the sorting function outputs an actually sorted array of elements with respect to the criteria followed in such ordering. Say for instance when we try to order a list of persons by their name and surname. Next, a property law or invariant with relation to tests is a characteristic that the result or output of the execution of certain piece of code has to comply with. However, not every single piece of code will have neither the same set of rules nor present the same difficulty to define such rules. To clarify this, we won't define the same set of rules to test our sorting function than if we were to test Dijkstra's minimum path algorithm for a graph, right? The defined set of invariants or rules is going to be different. Here in the screen you can see some of properties that were defined for the sorting function we said before. Next, what test generation means, right? In order for us to be able to thoroughly test our code, we need a variety of inputs that will match to an expected output at the end of each test execution. As it is impossible to test the whole set of inputs to an integer array sorting function, for instance, we need to pick a subset of inputs to feed into the function or functions on the test and see how these behave. Here's where random things come into play. Well, non-deterministic execution is a pain, right? We all know. If something is widespread in computer science, is that randomness can drive us crazy sometimes. This ad hoc random number generation thing can produce some correct inputs that make our test finish green, but in some other cases, we're screwed, because things can get bonkers and make our test fail with a random input that doesn't work. What do we do then? Well, that is what my colleagues are going to explain later on. So my part is finished. Enjoy the presentation.
Thank you, Daniel. After this great introduction, I'm gonna try to make you understand why is it so interesting to use property-based testing. There are three main features I will talk about in my part of the presentation. First of all, the coverage. Imagine we have a simple serialized function and we want to fully test it. We would have to run through all the possible combinations of params and instances, and that would be obviously tedious. So, an alternative to such test would be to rely on properties. It would offer an exhaustive coverage of the possible inputs in an extremely random way, and if we have a deserialized function, our test would be as simple as this. All these parameters you see here will be later explained by my colleague Luis, so I'm gonna skip this part if you don't mind. Well, if you do, okay. Another very interesting thing about FastCheck is that it is reproducible. we are all tired of having to repeat every test just because one case is failing. What FastCheck uses are seeds, that is that you can replay the same test after a fix, even if the inputs were completely random. When FastCheck detects a problem, it will print an error message with the settings to replay that specific test, and then we just have to specify them here. And the last but not the least, its ability to shrink. Imagine the following situation. You are developing something and you run a test. Of course, it fails. So you have to spend 1 hour or more trying to find when exactly it is failing. So FastCheck eases your investigation by providing you with a minimal test case. You just have to put this line of code, execute the test, it will fail again of course, and then you will see the message looking like this, showing for what cases it is failing. The nice thing here is that, for example, if a function breaks with an input of -50, FastCheck will try again with different inputs until it finds the minimal case. That could be, for example, -1. Okay, in case you are still wondering who could be interested in using FastCheck, I will show you some examples. This guy on the left is Nicolas Dubian. He's French. It's the main developer and collaborator in GitHub. And here on the right you can see part of the team. When I was looking for information, I found a curious thing, and it's that they are very, very proud of their project. It's like a happy team. They show where was FastCheck used, they always invite people to collaborate, the issues are full of ideas, good vibes. And of course, you as a software developers, I really think FastCheck is very useful, so I hope you are interested in it and use it in some moment of your life. Well, just to finish, I would like to show you some examples of packages using FastCheck. Jasmine and Jest are testing frameworks. List is like a immutable alternative to ArrayList. Query string is for parsing and formatting URLs, and Regulex is my favorite one. It has nothing to do with the subject, but it's like very fancy. You can give a regular expression as an input, and it outputs a graphic with possible paths. It's so cool. Now I will let Luis explain the funny part.
Well, I'm Luis and I'm going to talk about FastCheck code. First of all, we need to have a test framework, because if not, we cannot use FastCheck. In this case, I'm using Jest because it's the one that we are using in the labs. We can install the module, the dependency of FastCheck, and now the things will start. Let's say that I want to test my method on the left, which is inversor, then on an input boolean value returns the contrary one. We will have to do something such as this. We must state a property which says, in a natural language, can be read as, on a boolean input it is expected that the output on the inversion function with that boolean input is equal to this expression, which is indeed the negation operator with the boolean value. But how do we know this boolean value? This is generated by means of this. This is an arbitrary. An arbitrary is a generic implementation of a generator of random values of every single data type that you can even imagine. And everything is provided by means of FastCheck. So you have the input, the random input, and you have the rule to be checked. Then you enclose it by means of the assert, and you ensure that it will be checked a lot of times with a lot of different inputs. In this case, it would be 100 times. I know that for a boolean value it's not really that useful, but talking about what's next, which is numbers that can be natural, negative, floating point, you can change the var size, and talking about the strings, you can change encoding, you can change the size, and even you can format them, making them look like IPs, URLs, emails. Can be really useful to have such an amount of repetitions in the tests. In fact, this can be actually really useful talking about tests or validators thinking in other subjects. But sometimes randomness is not that good, and we need something that is fixed because we want to check something specific. Okay, you just put dot constant, and the dot assert won't select a random value for that. In fact, you can make it choose among a given array of values. You can generate arrays of arbitrary stuff. You can generate some arrays of arrays of random stuff. You can generate sets of random stuff. So you can generate a lot of data structures of randomness. Okay, but let's say that you need something that is not in FastCheck. It's quite difficult. It may be even impossible, but configuring this class, you can generate whatever input you need for your tests. So it is provided by the module also. So you won't have to use another one. Now I need you to recall data structures. You need to recall how to build how we built a tree in the test and how that was a pain in the ass. Okay, just with 4 lines, I'm reading it right now, you can generate a tree. This is a recursive constructor. Well, with recursive constructors, okay. You know, I'm calling here a tree. Imagine that I'm stating here that the maximal depth is 10 by default. Okay, then it will say, hey, a tree is a node or with the length or a leaf. A leaf is just a natural number. Okay, and a node is, if we are not in the maximal depth, it's just a tree and a tree. Okay, a tree. Then a node or leaf. And you can generate recursively a totally random tree, which is, or in this case, it would be a binary tree. If you want it to make even more random, you can use this structure. But with this structure, I must say that you are in risk of collapsing your computer because there is a small probability that you generate an infinite tree. Having said that, much more power is good. And to finish, it's important to comment that everything that I have commented with the arbitraries can be modified, transformed, and so on with math, filter, and reduce. That the module provides the command test pattern that states a precondition, execute something, and then a postcondition, and that everything that I have commented until this point, including commands, can be done asynchronously. With race, you can handle the race conditions and state schedulers and so on. And this is the end of the code part.
Thank you, Luis. Now I'm going to talk about some other aspects of this property-based testing framework. As we mentioned earlier in this presentation, the FastCheck framework allows us to test any kind of number or string values, and there it is where the FastCheck API enters in the game. We have on the left-hand side of this slide the classes, or some of them, because we have 2 remarkable ones. First, the arbitrary. It is an abstract class able to generate values of any type t. We also have shrinkable. This class, as its name says, can shrink a t value into t shrink values that are indeed smaller. But also, in this API, as some of my colleagues said before, we have functions because FastCheck is filled with plenty of functions for any kind of data type. We have some more general functions like the method anything that allows us to test any type of values we want to use. This method accepts also a optional parameter settings to give some constraints to the function. Nevertheless, there are also some functions that are focused on more specific cases. We can find ASCII string, for example, for strings of ASCII characters, but also other methods like double, float, and so on. I'm also going to talk about quality attributes, because why should we use this property-based testing framework? First of all, it offers plenty of types, because FastCheck gives us strong and up-to-date types, which allows to test any kind of property we could think about as programmers. It is also extendable, because it is able to derive existing arbitraries while keeping shrink, which was explained by Sofía before. We also have filtering options. Invalid entries can be filtered directly inside the check function. This is indeed very useful. Also, FastCheck adds debugging advantages. We can replay the minimal counter example, which frees us from replaying the whole sequence. We can find also race condition detection. This is due to FastCheck being able to detect any race condition in our code thanks to the power of property-based testing. Now, I will talk about the maintenance of the GitHub repository where FastCheck is developed. As we have seen in the past few weeks, some other technologies are less maintained in the repositories, with issues opened and not being updated very often. On the contrary, in the case of FastCheck, we have more than 240 issues closed and over 30 issues open right now. Regarding its releases, FastCheck has a total of 81 versions since it started developing 2 years ago. Nowadays, its latest release is the 1.23.0, which was released a few days ago. And that's it. Thank you for watching us and keep fast checking. Bye!